Hello and welcome to another episode of the Oxford Online Maths Club. My name's James and I'm trying to come to you over the internet over a pretty bad internet connection. I think it's maybe working, maybe not. We're going to find out. I'm just going to talk to chat. Oh, I haven't even got chat on screen. Let's find out. I turned everything on and off and on again while I was trying to get my internet to work, so let's see if we can get that going. Get some chat in here. No, I don't think I've got enough internet for chat either. I've got 99 problems. It didn't break. I am here. I think I'm currently live. We'll see. Here we go. We get some chat. Sounds good. I think it's live, says Drish. Let's go. Recent in there in chat. Bit of a setup. The problem is if I switch everything off and on again, then it's not there. Are we good? Audio's good. Video's a bit PowerPoint. Irritating. Okay. I can work with that. So last time this happened, I just cancelled everything. Quite laggy. Yeah, it's laggy for everyone. Okay, but we can hear. Okay, so we're going to do a pretty low frame rate kind of experience, I think. I think I'm going to power through it. We'll do a short one. We'll do a short Maths Club episode. Let's see the rest of my setup. Yeah, there's going to be no video on this. Let's see if we can get this. It is live, choppy. You can still technically... Okay, technically is all we'll take. Fixing the internet as well. I haven't even fixed it, and it's still taking up all of my prep time. Hi to everyone. Hi to people in chat. Hi to Ali. Hi to who else can I see in chat? Magnus is here. Hi to Raphael. There's a name I've seen before. Yeah, this episode also brought to you by Microsoft PowerPoint. I don't even have my presentation ready. I just got. Oh my word. Here we go. So I'm going to describe the thing that I wanted to tell you about. If I cut out at some point, if it all goes away. Then your homework is to try and work out what was going on and to try and draw it yourself. It's another drawing join the dots sort of activity where the lovely video of me joining the dots is going to become a sort of slideshow of me joining some dots. Thank you to Christian in chat who's been moderating chat as we try and get things switched on at the start and as we try and get going. I'm going to start doing stuff. Right. It's a little doodle that I saw, I think for the first time in a maths class, and then I saw again a few years later in a different context, but yeah, putting different things together. I know what the answer is to this problem. I'm going to try and work it out live, and we're going to see if we can do that. Ooh, there's no vector calculus this week. Maybe some vectors. Goodness knows. Oh, I don't like this. It wouldn't be Oxford Online Maths Club to someone without some technical issues. That just makes me a little bit sad, right? Is that what everyone thinks? Do we always have technical issues? He says, coming to you live at 2 frames per second. Right, okay. Here's how it works. I've got some axes. I've got some points on those axes, and I'm going to join them up with straight lines. The rule is that I'm going to start up here at the top. Describe what I do as well. And I'm going to join that one to the first point over on the x-axis. And then I'm going to come down to the second point on my y-axis and join that to the second point. So I'm working down the y-axis and across the x-axis. So I'm going to join the third point here to the third point over here. And I think this was the sort of doodling that the cool kids did at the back of maths class instead of learning about maths. So joke's on us now, I suppose, because now we're doing it in maths class. 1, 2, 3, 4, 5, 6. People who saw last week's episode will know that I always make an intentional mistake when I'm doing this sort of thing so that you can do it better than me. It's inspirational. I don't think I'm going to Oxford purely because of the dodgy Wi-Fi. Right, okay, advert. Wi-Fi. Advert, this is coming actually not from Oxford University but from my house. So you can come to Oxford and have decent Wi-Fi so long as you don't buy this house. You know, that's me sticking up for the University of Oxford. It's my problem, not the university's. Yeah, the live stream comes from my house because it started back when, do you remember when everyone was at home? And it started coming from my house because that was where I was. And it's kept going. Joe's seen this before. It's making a curve. Oh, someone's done this with string. Brilliant. Yeah. Christian's defending the Wi-Fi too in chat. Says the Wi-Fi is not always that bad. Thing is, once I've done this, it's going to be quite static. We can look at it together. There we go. There we go. That's quite nice. The string makes a sort of curve. Ah, Alfie's seen this in a GeoGebra tutorial. Good stuff. So I think I'd done this before, and when I was at school maybe, or I'd seen somebody else try this. Something you can do is fill in the other corners as well to make a kind of pointy shape. You can do it on a pentagon, you can do it on other angles. I've picked two angles at a right angle because I've picked two lines that are at a right angle because I'm a square. But if you go for a different angle, you get a slightly different effect. It does look a bit 3D. Should we finish it off? It does look a bit 3D, doesn't it? Somehow, humans are amazing, right? That I draw all these straight lines, and it kind of looks like there's some curve here. Yeah, it also looks a little bit 3D in some way. Like it's I wonder if we all agree on how it looks 3D, right? Does it look 3D to the same way to different people? Because it's flat, it's a 2D shape, but to me, I think it looks closer in the middle than it does in the middle here than it does far away. It's an entirely new innovation, this sort of podcast maths where we draw things and talk about them. Nobody's ever done a maths podcast before. That's not true at all. Like, people have done loads of things. Oh, envelopes. Yeah, so there's this word envelope that someone's just put in chat, which I think I first saw the word envelope in this context at university, where there's sort of a family of lines, and you talk about the envelope, the outside shape that they live in. I've lost count now. 1, 2, 3, 4. This is my fifth line, so 1, 2, 3, 4, 5 is going to go here. It's where I pretend that this is incredibly difficult and I'm getting it wrong on purpose and stuff. Okay, good. Here we go, and join that one to there. It's nothing like a little bit of live. Okay. Content. Has the frame rate got better, or is it still a sort of slideshow effect going on? Yeah, there's squares going on. If you think they're squares, well, I mean, there's these bits where the lines cross each other, they look squares, and maybe the squares are bigger in the middle, so they look bigger and it's sort of curving maybe away from us over there. Not sure I did that one right. Oh, I missed a point. I always let you do it better at home. The one you do at home is always better than the one I do live. I don't think they can see that. The quality's too low for them to see this. Still laggy, still bad, still 1 frame per second. Brilliant, there's only one thing happening each second, so maybe that's fine. When I start doing the maths, that's going to be really painful. Okay, we'll tell you what, we'll try and do about 20 minutes, half an hour, before it just gets too much motion sickness for everyone and we call it a day. Last time this happened, I just cancelled the whole thing and scheduled it for the next day, but this time I think I'm going to just give it a go. See if I can do this, see if I can power through it, right? I want to show you this shape, even if I can only show it to you in multiples of 1 second. Oh, dearie me. Is anybody actually feeling ill yet? We've moved to stop motion animation. Yeah, it's gone much worse, hasn't it? Oh, stop motion animation can look quite smooth, right? When you've got lots of... So stop motion animation is where you get lots of frames, lots of still photos put together to give the illusion of motion, and this is lots of straight lines together to give the illusion of a curve. My plan for today was we're going to try and work out which curve it is around the outside, because somebody told me what it was once, and that made me want to prove that it is what they said it was. Maybe you've already been told what the shape around the outside is. Ah, that's not silly at all! A bird's eye view of the Eiffel Tower! That's, by the standards of this live stream, that is an intellectual comment. Cultured. Excuse me, this is the Oxford Online Maths Club. You're absolutely allowed to mention things that are in France. Right, what are we doing? Everything's melting. Everything's overheating. Yeah, okay. Cool, right. Good, there we go. Doodle, right, let's ruin it by turning it into maths. Everyone loves that, right? So somebody told me once that this shape around the outside is... I think I'd always assumed it was like a quarter of a circle. There's a separate problem where the answer is a quarter of a circle, but so I sort of maybe always assumed that this was quarters of circles, right? And that maybe this is some cool way to draw a circle. I think I was imagining sort of tangents. Each line, by the way, is tangent to the curve. This kind of imaginary curve around the outside. Each line is tangent, so I guess I was sort of imagining circles and sort of things going together. But it's not quite a circle. You can sort of see if you turn it sideways that it's too flat. It looks a little bit like Kosh. It's pretty cool. It is in fact, Dirishlay's heard the same thing as me in chat. It is in fact a parabola. And my plan was to try and work out why, or to try and show you why it's a parabola. My plan for doing that involves doing some mathematics to work out, is this shape here a parabola? A parabola is one of those things that some people know loads of facts about parabolas. If you're Isaac Newton ages ago, then you know lots and lots of things about parabolic equations and things. But for me, I'm good at the quadratic formula, I suppose, and good at x squared equations. So I'd like it to turn out to be some sort of x squared equation. Oh, Kosh in chat. Can someone helpful in chat explain what Kosh is? And someone anonymous in chat is about to learn what Kosh is, which is brilliant. Someone helpful in chat will explain. There's a challenge for chat. Be helpful. No, the challenge is to explain. The challenge is to explain Kosh. Right. Okay. So my plan was to write this on a whiteboard. I really think this is going to be. Oh, this is going to be a little bit awful. We'll do a bit of this, and if it gets too much, then we'll turn everything off and on again. There we go. Let's put this over here. Let's put this nice and large. Fully smooth motion for me, and I'm not even still not loving it. Right, good. There's the quadratic formula. Somebody else in chat, big fan of the quadratic formula. Plus or minus the square root of, yeah, it's so hard to type maths in chat, but people are doing a good job there. Okay. So here's the twist. People in chat are explaining Kosh. Somebody's remembered a previous episode of the Maths Club. We talked about it being, or did we do this? The shape of a hanging rope or hanging string. I did that on a previous episode of the Maths Club, I'm pretty sure. And some explanations. Here's the twist is, if the person who asked what is Kosh, if you're watching, could you let people know in chat whether they've helped or not? How helpful has chat been? You can decide. Is that a Desmos thing? Great. Yes, good. That was with Joanna. It was a really good episode. It was quite hard, which is sometimes what we need. Good. Somebody might even find out what episode it was. What I'm doing here is I'm delegating the admin of the Maths Club. I think it was last term, I think it was season 3, and I think the episode's called Hanging Chain or something like that. So I might be able to find it. Right, so my plan for this is to try and do some maths to work out that shape is a hanging, to work out, not the hanging chain, did that before, to work out that thing is a parabola. My plan for this is to turn it sideways. With the curve this way round, orthogonal. This parabola is a little bit strange. It has, I think, quite a strange derivative where it meets the axes. So I think it is a parabola, but kind of rotated. I think this one's a parabola too, but sort of rotated. I think it turns out that rotating it like this around 45 degrees and talking about this problem with the lines set up like this makes the picture look more like the Eiffel Tower, and it makes the parabola easier to find at the end. Or I'm hoping Christians checked, are these obscure, complicated Rickroll links, or are these people being helpful and showing us where to find out about hanging chains? Good, right. Thanks, Christian, moderating chat. It's astonishing how much chat moderation involves just checking what it is that people are linking to. Can't see anything. Oh, bother. Didn't switch. Right, instead of having it this way round, lined up with the axes, I would just like to think about having it 45 degrees around like this, so that it looks more like the Eiffel Tower, and also so that parabola up the top works out. Sorry, that was on me. That was not even the internet that time. Christian checks all the links. Be very careful. Right, good. Okay, that is not a challenge. That was blank grid. Yeah, thanks everyone. I'm going to blame the internet. I shouldn't blame the internet. The screen went up. Yeah, okay, everyone's in now. Sorry, everyone. So it wouldn't be Oxford Online Maths Club without some technical issues. This way around, so that this parabola, rather than having this way around where it has some sort of weird gradient near the top, lined up with the axes, I'd like to draw it sideways. OBS says that I have dropped 51,000 frames, which is a personal record. Right, okay, we're going to very quickly do a bit of calculation, and if that fails, well, so be it. Okay, let's go. Okay, so we've got all these lines, and I'm going to try and write down all those lines. It's gone laggy again, hasn't it? It's gone really laggy. So we've got all these lines. I'm going to think about lines. So I've got my two axes like this. I've rotated everything 45 degrees. So I suppose this is the line y equals x, and the other one is the line y equals minus x. I'm interested in these kind of lines that start over here somewhere and end up over here somewhere. Okay. Somebody's got invited to the PAT preparation program. Brilliant. That's going to be a lot of fun. I'm not involved in that. The physics department is doing that one. It's going to be great. Harriet's stream has improved. That's good. Maybe using this as fix things a little bit. Who knows? I am going to be around for the open days. I'm organising some of the talks, and I'm doing the first one at the maths department where it says maths at Oxford on the open days in Oxford. That's me, and that'll be live. So that's not going to have this internet trouble. Okay. I would like a parameter to explain how I'm sort of moving this line, moving this point down here, and at the same time I'm moving that point up the other axes. So I'd like some sort of parameter to explain how I'm moving this one in and that one out simultaneously, so that I suppose if they go constantly, if this one starts at 1 and comes down to 0, and that one goes from 0 up to 1, I suppose I want this point over here to be, well, maybe I want the point on the right. It's going to start from 0 and go up to 1. Maybe I'll call its coordinates something like, I need a letter of the alphabet, something like C, C. And then I'll go between C is 0 and 1. Ooh. Okay, those are my graphs. Do they have different slopes? Yeah, they do have different slopes. One of them's y equals x and one of them's y equals x. Oh yeah, this pink line is going to have all sorts of different slopes. And first I think I'd like an equation for that pink line. I'm trying to work out how the problem is sort of set up if I did lots of different lines. So maybe I've got this point CC, I've rotated, so point CC, so this is going up this line. And the other ones, what A-levels did your internet do, James? It's going to be C minus 1. I'm going to subtract 1 so that it's following behind. 1 minus C, I suppose, because it's on the line y equals minus x. Which is a bit painful, isn't it? Yeah, something like this. Y equals k. Okay, so this is an equation of a line in chat as well, which I'm not going to check. So my internet did A-levels in maths, further maths, and French, and not in IT, which is the big problem. There we go. Right, okay. So I think homework is find the equation of that line. I'm considering dropping this because it's not going very well. No, let's do the equation of the line. Let's write down an equation of a line and then leave it as kind of... okay, we're going to keep going. Watching this is optional, right? I say watching in the loosest possible sense. Engaging with this content is entirely your choice. It's completely up to you. So, it's there if you want it. This is an excuse for it not being very good. Right, cool. Okay, I think the equation of the line, after doing some sort of A-level sort of maths, is this for that pink line, in terms of C. So I had to think really carefully about the 2 points that it's going through, CC and C minus 1 and 1 minus C. I think really carefully about those and work out this equation of a line. This is really good because it says that if I'm at some point on the line, then I can relate together where I am, what the point is. I can relate that to what the gradient is. So my kind of envelope curve, the thing that I'm trying to find, this mysterious purple line, which curves down and up again like this. If it goes through this point here, where it meets this pink line, then I know there's some relationship between the value at that point and the gradient, which is kind of captured by knowing the equation of the pink line. Oxford's not providing bad Wi-Fi. James's house is providing bad Wi-Fi. We did this one. Maybe this is a bad advert for the university. I should shut this down before everybody gets the wrong impression. Okay, so my strategy, I think, is to go at a point AB, so at some sort of random point AB that's on the curve. I know that that's on this pink line, because it's right, the pink line's just come through and being tangent to the purple outside curve. So I know that I'm on the line. Come on, we can do this. We're going to write this out and then maybe call it a day and come back another time. Yep. And what I want is to get, I want 2c minus 1. If I can get 2c minus 1 in terms of A and B, which looks easy because 2c minus 1 is in that equation, but it's actually hard because I want it in terms of A and B and not in terms of C. So I need to solve this equation for C and then rearrange. So it's a quadratic equation for C, we can solve those. Rearrange it to find C, and then I'll find 2c minus 1, that's the gradient. If I can work that out, that's the gradient of the line. It's also the gradient of the envelope curve, that purple curve. That's got to be my ticket to proving that this is a parabola, because then I'll know the gradient in terms of A and B. Or said differently, I know that at a point on the curve, I'll have a rule for what the gradient is on that curve. Right. So bit of quadratic equation stuff. I'm skipping the details because you won't get to see them anyway. Bit of quadratic equation stuff. It turns out that solve the quadratic equation and stuff, the gradient is this. It is a plus or minus the square root of a plus 1 squared minus 2 times a plus b. Oops. Square root. Oh my word, which is awful, but does give me a rule to say, aha, that is the gradient for my curve. It's the gradient of the line. It's also the gradient of the purple curve. In terms of, I could relabel this in terms of x and y. Yeah, maybe I can't relabel this. Who knows? To take my general point. We've got nothing. We're gonna. Write that down. My words, this is my plan to work out that, aha, there's some relationship between a point on the curve and its gradient, that's sometimes called a differential equation. There's some relationship that comes from something to do with working out what the line is, and then working out, based on the gradient of that line, that tells you the gradient of the curve. Where I need to do some sort of A-level maths to work out the gradient, some quadratic equation stuff, and then I need to do some sort of rearranging stuff to write down that gradient. If I do that, then I'm faced with a horrendous differential equation. dy by dx equals some hideous function of x and y's. I've used this trick where I referred to my specific point I was interested in as a comma b, but then it's true for any point on the curve. So I've switched to using the more conventional x and y, so that it looks more like a happy differential equation. Yeah, instead of finite points, like infinite points, a cleaner and more precise curve. Maybe that'll help in some way. Not sure. Yeah, so I guess I'm considering all real C between 0 and 1. So I'm considering this kind of smooth continuum of curves. I made a Desmos thing for this. I'm not entirely sure if I'm going to be able to show you it. So anyway, it turns out you can solve this differential equation, which sounds incredible, but actually the way you solve it is to guess, maybe, there are multiple ways to solve it. You don't have to guess, but one way to get to a solution is to guess, what if this bit is 0? But what if this bit is 0 inside the square root? The square root is really horrible. If that bit inside were 0, then, well, we wouldn't quite be done, but it turns out that is enough. Coincidentally, perhaps, the rest of the equation, it also works out nicely, and that it in fact gives you an expression. That thing inside there is some quadratic terms in terms of x and a y, so you could rearrange it to give you a quadratic in terms of y as a function of x. So the differential equation is absolutely horrible, but luckily, because we set the problem up hoping that it will have a sensible solution, turns out that a solution, I'm going to stress that it's a solution, is y equals, so the 2x cancels out, there's a factor of 2 that I need to remember, it's y is x squared over 2 plus 1 over 2. It just works. And you can check because dy by dx is, when you differentiate that, you get the x squared over 2 differentiates to x, and then the square root bracket is all 0, so it doesn't matter. That all goes away as well, just because we made it go away. It's a really weird differential equation though, and something that, you know, all the mathematician parts of your brain should be shouting at the screen that A, this frame root's terrible, and B, you can't get away with all those square roots like that. You can't get away with solving differential equations by guessing them. I suppose I'm trying to provoke you into something else should be something else should be at the back of your mind for what's going on. There's other questions you could ask about this. Okay. I think I'm going to stop there. So I'm going to leave you with this kind of tantalising collection of maths. Not quite enough to understand exactly what's going on, but enough that you've got maybe an idea that you could do this. I think if you've done enough A-level maths to know roughly about what a derivative is, and to know a little bit of differential equations, and to be able to plug things into each other and do quadratic equations, then I think you could fill in the details to get down to that horrible differential equation at the bottom. And then, hard question, think about the differential equation, think about other solutions to that. Why can I make it just 0? Yeah, well, I guessed, and it turned out that was fine. And I have more complicated things that I could say, so there are other ways you could phrase this. I'm trying to provoke you by saying that I thought about it in terms of just guessing. But there's other things you could say. So you could say, write y equals x squared over 2 plus 1/2 plus some other function, z of x, no, let's call it f of x, or some other function, f of x, and then prove that f of x equals 0. That approach is slightly easier and it's much more mathematical because you actually prove that f of x is 0, therefore y is this function, x squared plus 1 all over 2. But maybe that's not very satisfying because although if you follow that through and you solve the differential equation properly, then you've proved that that's the solution. That doesn't tell you at all how I thought of that being the solution or where that came from. So as a mathematician, you sort of need both. You need, on the one hand, the ability to follow things through technically and prove that something is correct, but on the other hand, you need some sort of intuition, you need some sort of guess so that you've got something to try to prove. You absolutely need both. I have a Desmos thing for this. What I'm going to do is I'm going to put it here, and then I'm also going to put it on screen, and it won't be very impressive. I might also try and put it in chat. This is if my thing works at all. Casey in chat says, what would it mean graphically that we turn the whole thing inside the square root to be 0? What does that actually mean graphically? Yeah, it's a good idea. The plus minus square root is actually really subtle. It's quite hard to explain what its role is in this argument. We're imagining, in a way, all of the possible points on this curve, and also we're sort of imagining some points that are not on this curve, and talking about what the gradient would be at those points, which doesn't make any sense. If you're not on the curve, then you don't have a gradient, so it doesn't mean anything. This differential equation, technically, it defines what the gradient would be for any values of x and y, which is mad because most points at x, y are not on the curve. Differential equations are a little bit like this. They define a derivative, usually in terms of x, I suppose, but maybe in terms of x and y like now. They define a derivative, and then most of that's irrelevant because the actual function doesn't take up that entire range of x and y. Anyway, somebody else asked about the difference between A-level and IB, and I don't have anything very deep or clever to say. except that I think A-level lets you do slightly more maths if you do A-level plus maths and further maths. Not enough that it's a problem for IB students in terms of looking at maths at university, but there is a difference in how much maths specialisation you can do.